Rin Jumplin.
Yes. Yeah. She thought it's the normal series, so she just asked for the ID. I said you need to register.
Good.
The key one. Hello, everybody. We are still waiting for more to check in. So please, let's wait for a while. Okay, we have 58 attendees, and for the session at the moment, I think the rest will just come in at their own time. we can actually start now. Well, hello everyone. Good afternoon, everyone. My name is Abraham Tang from Deconic, Thailand. Welcome and thank you for accepting our exclusive invitation to you. Okay, you are actually selected because your profession, contribution in the construction industry is of a recognizable impact to the industry, especially in relation to the door, window, and facade sector, directly or indirectly. Okay. With regards to today's topic, especially wind load, is a topic where many knows about it, but many also try to ignore it, sometimes getting themselves into trouble. So we would like to touch on this topic so that people will have a higher awareness, so that we can actually influence the market to be more aware of this topic and take precaution, especially in areas where there is typhoon, cyclone, high wind load area, and for those who actually are involved in high-rise project, you will definitely have to get involved in to know about this. Okay, I would like to give a brief introduction of Deconic. So today's topic is actually wind load for design of door and windows and facade in the Southeast Asia region. Okay, before I hand over to the rest of the speaker, let me introduce myself. Myself is Abraham Tang, Business Development Manager for Deconic Thailand office. Okay, together with me, another business development manager is actually Ms. Bo. She takes care of the Thailand market. Okay, let me give a brief introduction to Deconic Global. Deconic Belgium, actually established in Belgium in 1937. Okay, has been doing business for the last 82, coming to 83 years, and is now the world #2 window and door profile producer in the world. Okay, currently we have presence in 91 countries worldwide and 14 manufacturing plants. Okay, basically located in Belgium, France, Poland, Germany, United Kingdom, Russia, the US, and of course Turkey. Okay, and we are distributing our product across the world through 22 distribution centers worldwide, and Thailand warehouse is actually one of these 22. Okay, we provide all technical support to all our customers and partners so that everything will be all right. Okay, for Deconic Thailand is a subsidiary of Deconic Group. I think that's a given. Well, the office has been serving the Thailand and Southeast Asia market for more than 20 years. We also have customers that is in South Korea and Sri Lanka. Okay, it actually started as a subsidiary of Thyssen Polymer from 1998, and then later on it actually rebranded as Deconic, Innautic Deconic Thailand after the merger of Deconic and Thyssen Polymer. That happened in 2003. Okay, and eventually it becomes Deconic Thailand officially in 2019. Okay, in the early 2019, Deconic decided to unify the product brand to become a single global brand, Deconic. Okay, this is actually to make the business operation more efficient, so that it can actually help the customer as well. Okay, the warehouse of Thailand is located in Bangkok, the capital city of Thailand. Okay, with a storage floor space of 1750, okay, or 1,750 square meter. Okay, it has a storage capacity of about 14 tons of profile. Okay. It also has an in-house lamination facility offering variety of colors. Okay. This is actually to facilitate better logistic lead time for our customers. Okay. We take a look at some of the references that we have over the years. Okay, basically that's all I have for the intro of the Cornate. I will now hand over to our MD, Satish Kumar, for his introduction to the keynote speaker. Mr. Satish.
Good afternoon, everyone. Abraham, you need to allow me to share the video.
Oh, I stopped my, okay.
Yes. Nope. Sorry, we have a technical glitch. I'm not able to show my face. Abraham doesn't want me to show my face.
Is it?
Yeah.
Show your face.
I see something with the setting.
Satish, now you can try, please.
Yeah. Nope. No.
I exited.
You can just open your video.
You cannot start your video because the host has disabled it.
Now, can you try?
Yes, perfect.
Okay.
Okay. Sorry about the glitch. Good afternoon, ladies and gentlemen. It's a great pleasure to be here. This is the first time we are kind of organizing a webinar which is across Southeast Asia. We have participants from Sri Lanka, India to Singapore, and I have my colleague Brad here from Australia. So we are trying to do this across Southeast Asia for the first time. Please excuse the technical glitches if there's any in future. But the whole idea of this webinar was a common topic which Abraham mentioned, wind load. It's seldom seen, seldom probably heard. Okay, we read it in the newspapers that this cyclone is going to hit Philippines or going to hit the east of India, and we see the devastation later again on the news, but we don't probably experience it ourselves. So many times people ignore wind loads. So we thought this is the right time for us to introduce the topic, introduce the subject of wind loads, wind pressure, and try to decipher, because every country follows different code. So we thought let's get an expert speaker who is working in this field and get him to talk about his experience regarding wind, how he designs the doors, windows, facades, and how we can use it for making our own systems. Our customers can use it and offer better quality windows. Okay. So to introduce the speaker, Abraham, can you share the slide? So Mr. Binoy Das is our expert speaker today. He's heading facade concept design as the group CEO. They have office in India, they have an office in Vietnam, but they do projects across the world. Okay, they do have projects in India, they have projects in the Middle East, they have projects across Southeast Asia, Vietnam, Malaysia, Singapore, Bangkok. Personally, Binoy has been in the facade industry for nearly 2 decades. He has been working at different facade contractors, facade consultants, mainly being in the field of facade envelope design. Some of the projects which he's worked on are the Sheikh Abdullah Cultural Center in Kuwait, which has about nearly 90,000 square meter of facade. The Westin Hotel in India, which has about 56,000 square meter of facades. The biggest is the waterfront project in Colombo, which is about 400,000 square meters of facade. He's been a very active member of the facade group. He's been an active speaker in a number of conferences, including the IQPC conference in facade design in Doha in Qatar. He's been a speaker in Green Building Conference in Jakarta in Indonesia, and many more projects across the world. So without any delay, I would further hand over to Binoy. Binoy, welcome to our webinar. Please, it is your show, digitally your platform. Let's have this Binoy Das. I'll close my camera so that the bandwidth doesn't drop and create further glitches. So Binoy will start sharing his screen and do the presentation. After the presentation, we'll have the question and answer session. So there's a chat box where you can type in your questions. So after Binoy's presentation, I will read out the questions to him so that he can give his solutions, and we'll move forward. Yeah. Over to you, Binoy.
Okay. Thank you very much, Satish, and good afternoon to everyone, all the attendees and the panelists. I would like to thanks to Nick for giving us this opportunity to present on the wind load subject, which is for the facade and doors and windows.
Binoy sir.
Yeah.
Yeah, you can start your camera. Yes, now it is open. Thank you. Thank you.
Perfect.
So I would like to share a screen of my today presentations. And today presentations are covered into two phases. One is bit of tutorial kind of why the wind loads are required to consider rightly for the facade design in terms of your safety, in terms of your optimizations, factors and all. One sec. Okay, I hope everybody can see, right, the screen.
Yes.
Yeah.
Yes, Binoy.
Yes, yes.
Okay, so today the subject is the wind load, the importance of the wind load into the building in terms of your residential facade, where you have doors and windows, you have facade, which is a commercial buildings applications, or the continuous facade for high-rise towers, and what are the different wind loads and the categories of the wind load consideration with various analysis. So that's why I just wanted to run through it. So as I said, that there are certain key points which I would like to touch base, since most of the panelists and the attendees over here, they are pretty aware of the wind load requirement and the considerations. And after that, I will just run through a few projects, how the right wind load design can help us to design the calculation can help us to design onto the facade systems, whether it's doors and windows or the accessories or railings or a continuous facade. So first, I would like to just quickly get through like what is wind load as a definition. Like it's okay, it's a pressure or forces that the wind exert into the buildings or structures. So mostly, as we all aware of, that there are different types where the wind acting on that is uplifted, the shear wind load, and the lateral wind load. How does uplift wind load, like what are the factors, what are the areas where the uplift wind load to be considered? Like for example, we have a building with a roof or a canopy or a dome structures where your uplift wind load, how it reacts, the behavior of the wind load has to be studied. Secondly, your shear wind load. If you look at the diagram over here in the shear wind load, how the horizontal pressure, the force that can cause the wall or vertical elements, So these are different, where we need to consider while taking consideration of the wind load factors or calculate the wind load. Lateral wind load is something which is mostly onto the structures, but of course there's a facade. When you talk about the continuous facade or those there's all integrated connecting to the building structures. So these are certain factors where we are aware of. But I'm again just touch best those lines to give an idea about the calculation of wind load is not only is a theoretical calculation, but there are different elements which are required to be considered while designing the right wind load of a building, and that is required by the facade systems. So here, like the consideration wind load, like most of us as Indian engineers, we calculate on basis of your the geometry of the building, and then the simplified models of the wind loading and the grid. So here we try to also I try to show over here is that the wind which is acting on the buildings, whether it's multiple towers or a single towers, where the calculations of site wind speed as a function of terrain, topography, wind direction. So these are all, everything need to be considered, taking into consideration while designing the wind load. How about the external and internal pressure coefficients, then the dynamic effect of the wind. So these are the important part. We all probably are aware of this, but we need sometimes we have to think of implementing into this on the facade design. I would like to okay. As say like the nature and occurrence of the high winds. For example, for high wind performance of, let's say, the office towers, high wind performance of the office towers, where you have the envelope has a large part of the poor performance due to the inadequate design. Like sometimes when we design the facade, and if the wind load calculations or wind at certain heights or certain areas are inadequate, is not proper, then there are a lot of chance to fail in terms of your facade systems, where the structural failure, the water leakage to it, and there are a lot of other failures which can cost a use to the project owner, the building owner. So while designing the facade, the wind load calculations, different criteria categories required of, and the factors required in that conditions and that areas locations are important. That's why I just wanted to highlight over here is that when you design a wind load, the wind load design should gather all relative factors in terms of your wind temperature, then your prevailing winds, and then how does wind load, wind tunnel testing helps out, which I will come into the next slides. But what happens, like what are where the high winds, the nature and occurrence of the high winds, where we have a straight lines wind, we have downslope winds and the thunderstorm. So when we call about a straight line wind, this type of wind event is like it's a general to blow in a straight line wind speed runs from a very low to the very high. So high wind associated with intense low pressure can last for a day at a given location for that straight line. Downslope winds is like when the building is closer to some kind of the terrain, the mountain, or is a hill where the wind behavior of the wind acting on the downslope, how it's affected to the structures. So based on this, we have to design the wind load and finally get into the structure. I'll give an example, a small example. I think Satish must be aware of, whoever is in Mumbai. There's a project just nearby to in Mumbai, in the city Powai, which is next to a hill, where it's called a Supreme IT Park. It's an IT block, IT building, which is an inclined facade. So the building is just near to the small hill over there. And the 30 meters of the building height, which is below the ground level, the normal ground level. So there are a lot of wind which is acting, which you will a downslope winds, which is acting over the building at different phases, like the corner conditions, the surface conditions are behave differently, the wind acting on that. So the facade designing become a challenge over there. And when the facade is inclined, it's become a lot of challenges where we have to consider on this. The thunderstorms, as yes, when there's a heavy wind and heavy rain which is acting together, and then how does it affect how does it affect onto the building surfaces? So, and based on the facade design, we have to design the facade to withstand the wind load and also the performance. Like when there is a here, there's a water. So if there is a failure into the design of the windows, for example, or maybe a facade, so the wind can affect, and then can get the water also get into. So it's not only a structural failure, but it also could be a performance failure because of inadequate design of the wind load. So, like yes, for example, like in hurricane condition, like there's a system of spiraling winds converging with the increased speed towards the storm centers. For example, during the hurricanes or the maybe typhoon. For example, in Philippines, for example, in the Philippines, whenever the building is designed, I guess there are more than 15 to 16 type of typhoon, over there. So while designing the facade, we have to get the data, or maybe get the information from the local code of practice, get the information, discussing with the structural guys how their structures are designed, because whenever the facade is designed, the facade is a part of the structural, the building elements. So it is the whole moments of the building with the facade. So during the typhoon, and what are the different conditions need to be applied while calculating the wind load. For example, sometimes in the normal areas and where the wind speed is not much, in Bangkok, the wind speed probably of 25 meters per second. So in that areas, like there are different options of getting into the cost-effective design solution based on to the zoning of wind load. But in this, the hurricane or maybe a typhoon zone, where like in Philippines, like in of the few areas where the tremendous wind load acting onto the building, we have to go with probably with the highest wind acting onto the building. So highest design should be always be based on to the highest wind load consideration. So there are different types, the type of the wind which is acting onto that, the nature, and then the occurrence of the high winds. And coming into the wind and building interactions, like for example, there are positive and negative pressures. Like when wind interact with a building, both positive and negative pressure occurs simultaneously. So negative pressures always are less than the ambient pressure. Positive pressures are higher than the ambient pressures. So when the office building must have a sufficient strength to resist that load in order to wind-induced building. So the magnitude of the pressure in the function of the following primary factors. You can show a diagrams where the positive pressure, the uplift, and the sections. So these are all factored out. So what happened, like the characteristics of the ground roughness and the surfaces irregularities of the building, like there are exposure categories. You have B, C, D. I give an example where B is the roughest terrain and D is the smoothest. So exposure B is probably with the urban, suburban, or wooden areas. Exposure C includes with a flat open terrain with a scattered obstructions and areas adjacent to the ocean in hurricane-prone region. So as I said, so the wind, the wind load calculation always matter to the local conditions, the local code of practice. So any building to be designed for the facade, especially on the facade, has to take, we all know about take the local codes of practice. That is why every country has a different law, different codes. Like for instance, in Vietnam, it's a TCVN. In Thailand, they have their own code. For India, you have Indian standard code. So different codes of practice is used. In Hong Kong, it's BSCN. So this will help us to understand the local conditions, the local, the wind pressure, the wind speed acting onto that conditions. So these are the generic, like, yes, why do we actually strongly recommend for a wind tunnel test? Because, there are different way of calculating the wind load. Like there are a conventional way, we take the wind speed of, let's say in Thailand, Bangkok, 25 meter per second. So we take the 25 meter per second, we take the terrain condition, we take open or closed conditions and all the other as part of code of practice. And then we come into, as per the codes, calculate the wind load. But when you have a wind tunnel test, you get a accurate result of the wind coordinates acting onto the different areas. So that's why I said, like, wind pressure calculation is a significant factor while design of the facade, especially all the towers. It's not like for office towers or shopping mall or residential. So any facade which is continuous, therefore, especially for a high rise, and also for, I would say, the all facade has to go through, the wind tunnel test when there is a high rise or multiple towers are clubbing together. So that's give you the wind tunneling effect, that give you the different kind of coordinates. So, but when it comes to the developer, the mindset, like when they ask for how much it costs for a wind tunnel test, so it costs mostly of $35,000 to $40,000 for a wind tunnel test. So sometimes the way to save that cost, they do not go. There could be probably different reasons also, but what we come across that, okay, we need to save the cost. So why cannot we go for the other conventional way to design? Okay, we can go with the conventional way to design the facade with a local code of practice, but there could be a small chance of over design, because we are going as per the practice, as per the codes of practice. So we will just take the certain data which are available in the codes, and then you go use the formula, we get K factors, K1, K2, or whatever is that, and you get into that KPA level. But when there are multiple towers, it's always been recommended to go for a wind tunnel, because if we spend for a $30,000 for wind tunnel test, but we can save in the facade design, that saving amount could be much more bigger than the wind tunnel fee. So that's why I would definitely, if any developers are listening over here, I would definitely recommend and request to carry a wind tunnel test when there is a high-rise structures or there is a multiple towers are standing each other to understand how the wind acting onto that. Also now, apart from the wind tunnel test, apart from your conventional way calculating as per the code of practice, there is also a CFD analysis, which is for the wind simulations. If we don't go for a wind tunnel test, we can go with the wind simulations too. Wind simulation, the CFD wind simulation also can give you the certain results onto the wind coordinates. Because any building, which is maybe a rectangular or different shape of the building, I will come into the next slide, different geometry. So wind behave acting onto the building in the different directions. So we cannot take a mean of one points and then we design of this. We have to go with the zoning where the wind acting onto the level, maybe the plus 10 meter or 50 meter or 100 meter or 300 meter. So different zoning where the wind is acting on the surface condition, on the corner conditions. So we have to take all the coordinates, and to understand, to come up with certain kind of understanding how this facade will be designed. Because when the geometry of the facade changes or the building changes on gradually towards the height of the building, now if we all know about it, the architects, because of the facade designer, because of all this practice, all this technology, all this analysis are available, softwares are available to go through. The architects have a free hand to go any kind of complexity of the design. So the complexity of the design are as per the architect intent, as per the concept of the building. We as a designer have to make sure that achieve the intent, but also we need to check whether the intent which has been shown are structurally feasible in terms of your safety part of your point of view, in terms of the system which is going fixing onto the building, which is structurally adequate, where the building which moves along and the facade also has to move along with the building. There's an equal, the moments allow the moments into the facade, which is a continuous or maybe a floor-to-floor glazing system. So these are wind simulation, which is CFD wind simulation. Then you have the wind tunnel test, and then conventional way. So we can go with any of the design method, of course, but it's always better to go for a wind tunnel testing. If this possible, we should go for a wind tunnel test because it carries on as a prototype to understand, to give the correct results of the wind, the coordinates on that. So this is what, I would like to present, and I like to convey this message that why this wind load calculations with different type of analysis factors are important. Also, another part is like, okay, for the wind calculation, we go through the code of practice. Let's consider it the conventional way. We go through the code of practice, but there are other certain parts also include, like how about the prevailing wind? Prevailing wind is a wind direction from one to another. So how the prevailing wind also can help out. How the wind temperature, because that also bring a heat that it link to your total analytical factors over there. Wind tunnel test, which I've already explained about, wind load calculation or convention. But prevailing wind and the wind temperature, I would like to come up with a more brief on it. There are many things on the wind we can keep adding on, or we can keep research, or can go through whether it fit to designing onto the facade, or it can consider over here. So I think if we know about the wind rows, so wind rows is a representation of the direction in the wind blow in a given location. So you can look at the different data into the where northeast or different direction attached to the next direction, like west, east or west north, or southeast, south north. So these are all directions where the wind goes. The diagram you can see over here. So this is mostly what happened. Why you do need to, because wind load direction is a influence for the ventilation performance of building, where probably with a courtyard, or if those courtyards are located perpendicular to the wind rows diagram, that can summarize the distribution of the wind and the direction over the day on a defined observations period. So this we should actually to know about how this can affect onto the different type of the facade. So as I said, the architect's intent has the different kind of way they go with the play onto the facade elevation to look the building nice, where maybe nowadays the residential project mostly into the Middle East, they have continuous facade because it has to be a thermal proof because due to the heat outside 48, inside to be 24, so it's a insulation factor. So they always try to go with the continuous facade, where probably in between they create a pockets in between, and then they have a sliding windows inside over there, and then there's a glass railing. So how this wind acting on those areas? So this analysis will help us to review the intent of the design and can find out what kind of system required to be designed based on the wind load acting. So this is like a small slide where why it happens. When air hits in a tall building, so it pushes up, down, and around the corners. So in the different, if you see the graph, the pointers over there is that it goes up, it goes down, it goes side. So all directions well. When the air is forced downward, it increases the wind speed at the street level. This is very important because when you have a building, high-rise building at the heart of the city, or maybe at the crowded places, and you have designed something on your canopy or a skylight, mostly the canopy which is protecting out from the building. So because of this, the air which is forcing down, and then it increased the wind load. So there is always a sense of probably to understand the wind comfort over there, how the wind comfort over there. For example, when there is a certain areas where you have a walking or standing areas or pedestrian, or maybe the sitting areas, mostly sometimes you have an open court sitting arrangement with open restaurants kind of thing. Mostly in the Southeast Asia, there's a common where you have a outside sitting arrangement, and you got a tall building which is above you, and then there's a wind which is blow over there, which feel uncomfortable. So these are all things we need to consider. We need to think of, and also sometimes the facade engineer and the structural engineer has to walk together, discuss the effect of the wind load into the building, the effect onto the facade, and also into the structure of the building. And combinedly, if something we feel uncomfortable or feel something need to be changed, you need to point out, then we should go to the architect. They are the main design consultant or design of the building. So we should go and talk to them. We should try to find certain way. So initial involvement of any facade designer, I won't say the facade consultant, but any facade designer at the beginning of the projects are very important. It's crucial, because at that point of time, if anything need to be changed, then that can point out to the management, to the architects, and then that can be relook at those areas in terms of your, not only the wind into the facade. There are other factors in terms of your thermal comfort factors, in terms of your how the glare onto the different surfaces based on your sun path analysis. So these are very important part of the building in the facade design, which has to be addressed at the initial stages. So, and then we get into the facade design. We cannot directly get into the facade design going with some kind of taking a systems. Okay, this will work out, but there are different analysis which need to factor out, because every building they may behave differently in terms of your facade, in terms of your energy, in terms of your wind acting on there. So that is what I try to explain, try to present today. We all being as a facade, most of a facade engineer or a structural engineer, or maybe I would say yes, of course the manufacturer, like the accessories, or like the system manufacturer. Let's say about the Supo or about Technol. So we have to discuss, if we go with their system, we have to discuss, okay, this is my parameter, this is my requirement. And that's how we should consider and discuss with them to come up with some kind of solution, whether it's a bespoke systems or maybe so as I mentioned already about the wind tunnel testing, why it is important. So maybe wind tunnel test, it can scale models, we can get the different wind coordinates, and based on to that we can design. So mostly there is if it is a high-rise towers or a multiple towers which are situated, and also you have to consider about the nearby surrounding, whether it's a closed or the open condition, how many similar kind of similar height of the buildings are there surrounding, whether this is onto the very densely located areas, So all this will help out onto the wind tunnel testing, and probably this could bring us more economical when you have the design, wind load coordinates for the tunnel test. If not, then yes, I would say that wind tunnel test, as per our experience with the developers or with the projects, they go with when there's a multiple towers, but when it's a single towers with a 60-meter high or 70-meter high above and all, always intend to go with the wind load calculation. That's also okay. That's fine, but it's always better for a wind tunnel test. What I would recommend over there. This is a CFD. I already explained about. Okay, we all know about how this CFD. Then CFD analysis also can give us, probably the thermal comfort, the distribution of environment condition with a space, then the consequence of fire, because the spread of heat and smoke. Okay, so that's very important to also analyze. Then you have to have a effective natural ventilation, and then the built-up heat on the space of the servers, where there is the AHU rooms and all, how this facade ventilation. For example, in the AHU room, mostly we come up with a ventilated lowers. So what kind of lowers should be designed? That will depend on your the exchange here, heat exchange ratio, and also the wind which is acting over, and then how it circulates on that AHU area. That's all analytic part we need to come up. Though it's a air exchange ratio, it's a MEP scope of work, but also we have to understand how this wind flows, and when there is a different corners acting onto the wind of the building, how this wind acting, where the facade design has to take into a strong consideration in terms of your detailing part, so that it can last longer as per the design intent. Wind temperatures, yes, that is it's same like you have how the wind acting, and then the heat flow through the wind. That's again certain analysis we all about. No, I just quickly go through the other slides also, because maybe these are all theoretical and tutorial kind of things, which are all we come across. But we should take the importance. We should consider, and we should seriously think of taking into the the action of why all this analysis, which are important. We have to implement that on the project. We have to, if for example, a projects where we propose all this analysis, we try to explain it to the building owners, because then probably they will understand the importance of the requirement of your wind tunnel testing, which is cost. Where there is an internal process of analysis, yes, that can be done internally, and a qualified engineers or facade engineers who understand the facade in terms of not only in terms of the detailing, but in terms of the whole situations of how the facade behave in terms of your temperature, in terms of your wind, in terms of your the moments, so performance. So we have to take it all together as once before we get into certain design, and then we can further discuss with the manufacturer, like we can make maybe Suco, maybe Technol, maybe there are different manufacturer which can support us. We can support to design the right systems, or maybe also can follow our design, which is required into the building. Different code of practice, yeah, different codes we use. I will not go into the detail of these codes, but yes, we have to use the local code of practice. Now, I will just come up with certain some slides of a project which has been done in Asia in terms of your residential. So I divided into two categories because it's behaving differently. So for the residential, wind impact on the residential building. So there are many factors, when you design for a windows and doors, and calculate the wind and design for the window. So mostly the failure, we come across in terms of your designing of the windows. Let's say a balcony windows, we have a sliding track, four track or 3-track sliding, and you have interlocking profile. If the design is not done properly based on to the wind load acting over there is a water leakage. There is a whistling sound in between the interlocking profile, which at night you cannot sleep at night because of the wind which is passing through the interlocking profile. So the whole design elements, and then the shutters, which is window shutters, which are sliding shutters, which are acting sitting onto the track. The design, the thickness of the profile, design should be of the window should be proper. Otherwise, you cannot necessarily the roller which is fixing over there. That rollers may not work, or maybe tomorrow we cannot move the sliding windows. We have need to give external force to open the windows. So there are different there's about the wrong calculations or inadequate calculation of the wind load on the residential factors, which is purely is the main criteria, is the factors for the designing of the windows. Because window there is nothing much into. If it is a casement window, or it may be a window walling system, there is a performance. By any residential towers, residential building where the system is the main concern, your glass and the rollers and the accessories which can move, and your drainage, how it walks onto the track. Like when there is a water getting into the track, that has to be a proper drainage, the water to come out. So these are all based on your the design factors, and it directly to your wind load calculations. So here I would just go with the 3 slides, 3 projects. It is very small, few slides of that. This is a project in Mumbai, and whoever is from Mumbai, they know about this project called Nathani Heights. It is a 324-meter residential towers, and this is located into the heart of Mumbai, very crowded places, most with the densely populated areas, and very tiny spaces, because there is not sufficient space for this kind of high-rise projects to stand forward, because nearby is a railway station, very busiest railway station in Mumbai Central, and then all other surrounding, you have no space over there. And the challenges over here is that the facade, if you look from the elevational point of view, the facade are symmetrical, like it's the same. The design intent of the windows, design intent of the railings, you look at the elevation, it's a one complete design, one single design. But there is a challenges over here is that this building, which is before it was a slum, it has been what you call is a slum, and then this slum, the people out there, they have the developers that try to build these areas, and then they bring those the people who are already occupied before up to that slum areas, is given the occupation over there up to the 33rd floor, which is called as a redevelopment buildings. Okay, the rehab towers, the rehab areas block. So rehab blocks are not, the facade should be designed with a very cost-effective solutions, because they don't earn, the developers, they don't earn anything out of it. But above 33 floor, up to the top, which is 324 meter, is a high-end residential towers. So these high-end residential towers, you have the design element, we have probably with a very high specs design to avoid the sound, to air, water, and then it's a performance. It's called as a performance windows. So this kind of building, how do you take the challenges of designing the windows as a economical, as a cost-effective windows, and also a high-end windows on the same towers? So this is one of the challenges over here. And secondly, over the crown areas where the different the facade elements over there. So the wind acting on that areas are quite tremendously high. So how do you handle the design of the facade over there? So this is how where maybe the luxury floors where the high-end building, high-end apartments are there. So how there's wind acting over there. I'll show you on the prevailing winds. As I explained it before, the prevailing wind is important to understand the wind flow over there. So in this project, like in this building, see, you can look at this, the zoning of wind load. The zoning of wind load can do, yes, we can do the zoning of wind load to understand the wind acting onto the different level. Let's say, for example, 9 to 23rd, 24 to 39, you can look at the wind gradually increasing, but we are dividing that wind load. And this is a residential tower, so there are different ways to optimize the aluminum consumption in this building with respect to your wind load. We can also try to play with the aluminum profile, but aesthetically we have to make it, we have to make symmetrical as one design because it's an architect intent. So the elevation depth on the front side of the window can be remain the same, or maybe if it is slightly varies, also such kind of height will not be visible. But there is a different way, based on the zoning of the wind load, the window can be designed as per the heights of a residential towers. And yes, there are different facade systems. This is more into the detailing, so I'll just quickly run through this. The detailing, like, yes, when you design these brackets, okay, these are all related to your wind acting, wind load at that height, or maybe when it's a continuous facade. So you have to design something which, based on the wind load, where the structure, the base structure or substructures, which is connecting to the building and the cladding, it should be adequate to self-stem the, with the wind load, with your to the structural requirement. So the thickness of your profile, the thickness of your brackets, the length of the dimension of the brackets, what kind of nuts, screws, we all know about. So these are all depends on to the wind load calculations. So when you have a wind load, so then only we can have the right wind load, we can have the wind load. Sometimes what happens, like we take the maximum height of the wind load, but before, maybe I would say a few years back, still the wind load, the highest wind load at 33 floors or maybe 150 meter high, the highest wind load has been taken to design the lower part of the facade. For example, the retail area, which does not have a continuous facade. So we can optimize the facade design with respect to the wind load, your system design, your substructure design, your thickness of the framing, thickness of the glass, everything can rightly place. So we should not worry about whether this, okay, our design is over design or under design. If it is under design, it's a risk, and it's over design added to the cost. So it's very important to design right wind load to get all the design elements of the facade. Let's see about here how the system works. So everything will depend on your proper wind load calculations, and then and other factors in the performance. This is another in Vietnam, which is currently working. It's a mixed-use development projects where you have a 3 towers standing each other, office towers, residential blocks, and you can look at the view where there's a huge wind tunneling, could be the wind tunneling affected for the. So what will happen onto the just about the retail and the corner areas, and then on the corner side, how the facade design should be, withstand those the wind load, the actual wind load acting onto that, and then how the design can be done. So this is just it's commonly a same practice. If we understand the base of the understand the base of the design elements, and we can follow the same sequence of designing for any of the building. Let's say for the wind prevailing. So prevailing wind, on the different monsoon, we should understand, because that is also back to your water leakers. As I said, where there's a wind, where there's a air, there's a water. So we have to see to that the facade which has been designed, which is installed at the building should be free of water leakage, should be free of air leakage, or maybe the thermal leakage. Like, we should see to that if it is a continuous facade, because the whole elements of the facade design, when you go with the performance, your thermal transmission value, when you calculate it like ETTV or OTTV, so that is also lead to your total heat gain, which is inside the building, and it further goes to the MEP guys to design the air conditioning. When there is a facade leakage, then the whole the calculations will fail. Then if we design something, for example, of energy efficient buildings, or maybe whatever we design, if it is failed, then it become a very huge operation cost, and that has to be borne by the developers. So we have to be very careful on designing, and also follow the design when we fix it onto the structure, onto the building, and the right detailing should be in place. The fabrications, the installation should be proper. There should be follow certain methodology while installing the facade with a technical expert. So that's why I believe nowadays many countries they always try to appoint a facade consultant to help out, to remediate all these issues which could be later in the future. So okay, this is how the heights, wind changes normally, the wind calculations in the conventional way. Just find out. Then how would the glass, the thickness of the glass? Like, let's say instance where we don't calculate the glass thickness. We don't know what's the wind load acting onto that. Sometimes what happens, as I said, that engineer is very important at the beginning stages to analyze all these things. If not, then probably if someone come and propose, I need a 25.52 mm laminated glass, but why do you need a 25.52? Who has calculated? Who has checked based on the wind load? What is the wind load acting on it? So there should be a certain initial exercise has to do, either from the developer side, or from the architect side, or maybe from if there is a facade consultant, definitely the facade consultant helps on coming into calculating the right design, right thickness of the product. And this also could be lead to a help to finalize with the facade contractor the price of the facade, the cost of the facade. Developers should not worry about paying an extra, which is not required to pay to the facade contractor. I'm sorry to say that, but yeah, this is very important, where you have to understand the right design should be placed into the building. It should not be overloaded, or maybe it should not be over expensive, but it's not required. So that is why it's very important for designing or involvement of a facade consultant or an engineer, whoever the client or developers they like, or architect want to go, so they can bring them on board to study, to get on through all through. But just quickly run through. This is another one, which is the multiple towers. So if you look at the ground over here, see there are different buildings which are situated. It is in Mumbai again, and you have a huge site plan where again your the wind rows diagram, how this flows, and I would show you this. You look at the wind coordinates which have been calculated, and the different in the corners you have a different wind load. Wind load acting over here on the surface, there is a wind load, different wind load, and sometimes this helps also to optimize the facade, optimize the designing of the facade. It can reduce the aluminum consumption. It can reduce sometimes when it's a floor-to-floor thickness of the glass. So there are different ways the wind load can help to optimize the facade in this. So this is what, like few window elevations, where I just like to quickly draw. Okay, designing of the facade, how these members will be designed. So this purely based, depends on the wind load. If you look at this over here, okay, the A, B, and C zone, the wind load has different wind load. We go for it, okay, say 5 mm glass, 6 mm glass, 6 mm glass for the same window, because it's a flow to flow, and it does not, elevation doesn't make much difference in terms of your slight tweaking on the thickness. You can save you that. And then how is your, the performance work as per, if the design is proper as per the wind load you have, and the good detailing, you can also protect from weather, like water seepage, or maybe whatever is there, actually already explained in the before. Interlocking section system, if this design is proper, then it's a rigid. So whatever the wind acting over here with the glass and this composite, that will stand by, because it will stand to the wind. Design is as per the wind load calculation. And your intermediate section, which is this one, which is a very critical area where there is a sense of wind which is passing by, which is a whistling sound. It's sometimes very annoying. If we find this kind of at night, cannot sleep because of the wind acting, high wind acting through this junctions. Coming on to the track section, okay, there's a different profile can be designed. So window can be designed, it can also take the system supplier design. It depends on the selections of, but always whether you select a system supplier or maybe a own design on the facade, if you have the basic design intent, then you will definitely bring everybody into the apple to apple. So, over here, if you look at this is a small, profile which is added to protect from the rain which is coming inside. It can be protect from the rain, and also this section, the system which is designed, it has to be standards with the wind load requirement. You see at the track, the whole shutter which is sitting over there, the roller acting. If the window is not designed as per the wind load acting over here, then the roller will not work. The window may have can be failed in terms of section, glass selection, in terms of your section profile and all. And ultimately there will be huge water leakage and then air leakage, and then you have to replace the windows. So residential projects also equally important to take the design at the beginning stages when along with the architects. Then the structures also can be relooked, where the window is sitting over there, whether we need a sub-seal, or maybe we need an add-on profile, or we have to change the methodology of the window sitting onto the openings, position of the openings, whether you have what happened when the window is just flush outside to the structure, and if we install at the middle, or if we install at the inside flush. So there are different way this the performance, the function will affect. So how much should be the screw of the window of this profile has to be from the structure. How much, maybe in concrete, maybe there is always a coverage of 25 mm where the screw is not advisable. 50 mm, even not advisable. 75 mm from the outer surface of the structure, it can be done. So the fixing also, it's matters where the screw positioning should be there. How many screws, we have to, at what distance, center to center, whether you go with the 300 center to center, or we go with the 600 center to center. These are all will depend onto the complete design solution. So that's why window also very important part of any residential projects. So definitely it should take it into consideration. When the building, let's say now coming into office towers or any high-rise continuous facade, when the continuous facade, like, as a thumb rule, the facade area would be 25 to 30% of the built-up area. There's a thumb. So 25 to 30% of the built-up area is a huge in terms of if you rightly design the facade. So the wind acting over there, the different wind, which is same acting on the continuous facade is we have separately than the window. So our consideration on the wind acting over here also, we can go with the zoning of the wind load, and also how do we optimize when it suppose we there's a cost constraint about the facade design. The developers has a budget already. For example, $100 per square meter is a facade system or unitized system as a budget. So we have to also look at that budget while designing this. So the wind load acting onto the different zoning, there are different way can optimize. Maybe you can go with the inserting within the aluminum, so, or maybe you can probably use for a double bracketing system. So there are different ways the facade engineers or facade consultant, they come up with their own expertise. So this is just few examples of the projects, which is, I would say, the complexity are there, of course. The right-hand side two projects, which is a Kung Sri Bank and T1, it is in Bangkok. So Kung Sri Bank is a bank project where the complexity is like you have an external full height fence on the outside of the facade. And if you look at the facade over here, it goes, this is 25 meter, which is free span. The slab end up to here, and over 25.52 meter, the facade goes. So there's a huge wind impact over there. And then how do you design the facade with respect to the wind load? And top ground is a two-way, directions. It is not straight, so I'll show you into the diagram. On the right-hand side, if you look at this, the building is look like a twisted. So after certain height, the building goes with the different degree in plan. In plan, it changes in the corner. So when it plan changed the degree in the plan, so it slowly it goes and take the shape, and it successfully has been done. I would thank the facade contractors over there. Peterson was taken up this nicely. We had a great discussion between all of us to come up with the solutions. And there is a facade which is going straight and in and then go straight. So the junctions over there, the wind force acting over there, so different factors which work. On the left-hand side is a first tallest towers which is completed, Colombo City Center in Colombo. The challenges over here are said that you look at the facade which is continuous, you have a hotel and you have a residential service apartment. In the service apartment is a fully curtain wall, fully unitized glass. And when you look at those, these are all pockets. So pockets have the sliding doors, and then you have a railing. You can just imagine that it's a continuous facade and it turns inside, the glass is turned inside. So you have a force which is acting over here. It could be, that's why you have to understand the wind behavior, the wind flow at that area. Because if we stand in, nearby to the railing at residence and to view outside, because it's a fantastic view surrounding the Colombo. And we have to be comfortable. There should not be comfort because of the tremendous wind which is hitting us. So the factors are important. And then if you look at the podium, the car park area is a screen, is a huge metal screen with the cladding, 50% cladding and 50% opening. Like it's a 3 meter by 3 meter diagonal shape screen. So that has to be fixed onto the structure. So your wind acting over there, the whole reactions onto the structure, that has to be, you'd have to have a close coordination between the structural engineer and the facade engineer before you get into the, come up with the member sizing or the design intent over here. So just quickly go through it. These are the 3 projects. I've taken an example because I think we are from different reasons. So Kung Sri Bank, complexity, free span 25 meter high above terrace, vertical full height fence and the roof crown. T1 is the same Colombo City Center. I already explained that is a process where the wind calculations, we go with the zoning of the wind load. And zoning of the wind load probably, we may take, if it is a cost effective design solution, we may take the intermediate meat of the wind, for example, and then we design the facade. And above the mean, we can go for a reinforcement, maybe mild steel, hot dip galvanized reinforcement inside the profile, which composite way where probably the facade, the aluminum consumption can be lowered down, and structurally that pass through. So as I said, there are different way of engineers to project, the design intent. So you have DPT, like the Thailand code of practice, then how these calculations worked out with because we had gone through the wind load calculation in a conventional way. And look at the design over here. These are the fins, which are full height onto the panel to panel. So it's like almost 4.2 meter. I think like Bo, I think you are aware of this project. So this is it's quite challenging at that point of time how this wind, because it was a glass before and then further it changed to the cladding aluminum fin. So how the stack joints works over here for the unitized continuity. All this bracket design, your stack joint design will all depends on your wind load calculations and the wind load factors. So I just quickly have drawn. These are 300 mm fin, which is connecting. And then architects, Pamatana, they don't want any intermediate connections over there. It has to be point top and bottom fixes. There's a wind acting over there. So all this consideration you have to take. How the corner profile to be designed. The wind acting on over here at the corners are different on the surface conditions. So how this corner profile will design. You look at the top ground structures. Yeah, this is the facade, which is those the steel, and then the backside is a 25.52 meter facade, and you have a cladding and a different cladding form shape over. So this is very critical and very challenging, where the wind acting, how the design will be have to consider. So it's important for the design of the facade system. For the wind load, how the system will design. Okay, this is a system with respect to your structural calculation, with respect to your structural requirement, with respect to your performance. So how does this system can protect from the air, from the water, from heat, how the structurally the section which has been designed given, so can withstand the wind load and other movements, other required. So this could be a basic line where the owner can come up with, they can invite Suco, they can invite Technol, they can invite anybody, or they can invite the facade contractor to come and match to the specification or match to the section which is required. Because this is a design of the system which has been done considering the all analytical part. All analysis has been taken into consideration with respect to your thermal analysis, with respect to your structural wind load, everything. The glass is calculated, the glass. So this is the design elements which can be followed. So I want to say that it's very important to consider all these factors while we get into the design, decide something, and then we take further with any supplier to build the facade. And we will be sure that there won't be any water leakage, there won't be any problem on the structure, and we are safe for many years. How these corner junctions, or what will be the profile of how it's behaved. So in your seal part, which is important, if it is not designed properly on the stack joints, it will be a failure on the stack joints. And probably there's a huge risk on the unitized because it's a continuous facade. And if something is damaged in the frame in between, it's very difficult to replace the unitized framing. You cannot do except the glass. So you have to be very, very careful to decide a system. Before you decide a system, we must run through all this analysis. So how this is the two-step part where your facade is going in and out. So how do we take care of this? Okay, what kind of glass thickness we need to put? How the facade will move? How we hook onto the structure? And then how it behaves. So everything is very important factors, important part of the crown structures. This is a Colombo, I show you the screen. It's a huge screen. It looks small. A huge screen with the cladding over here, and then it's a box. And you have a wind which is passing through the perforations. So the end of my presentation, I would like to only say that, okay, like proper wind analysis on the facades are important, like to prevent from the system failure, water leakage, structural damage, casualties, and over-design, under-design. Correct wind load can help us onto the optimized aluminum and glass, save project costs, water air tightness, maintain performance when the facade design, or safety of extreme conditions. So I would like to conclude my presentations over here. Yeah, pass it to Satish, please.
Thank you, Binoy. Thank you very much. It's been really very enlightening to look at the different concepts of the facade design. You took us from why wind load calculations are required, what is wind tunnel analysis and why it is important, how the cost can be optimized by zoning, and your project references across Asia was really interesting, especially the complex facades which you did in Bangkok with the 25-meter crown at the top. So I think very, very interesting for the audience. There have been a couple of questions. If you permit, I would like to go into the questions so that we can try to answer some of them.
Okay.
There's a question about, if I can understand correctly, how to calculate the IY for the transims based on, because the wind load generally we're talking about the millions, but what about the transims? How do we calculate IY for the transim? Is it just the weight from the glass at the top or wind also?
Actually, the transom which are connecting between the let's say a unitized system. So the transom which is connected, the load which is further is distributed to the panels, to the mullion, okay, and then it comes to the brackets. So it is a definitely it's a dead load of the glass which is acting over there.
Right, right. There's another question, very interesting. I think you covered it in your presentation. Irfan asks how negative wind load is generated, and especially very high negative wind load, like negative 5 kilopascal, which is specified in a couple of tests. So why a negative wind load? I think in your presentation, you covered how the wind moves up or moves down when it strikes a building. Probably you can answer, Irfan, why or how negative wind load comes into play.
See, like for wind load calculation, both positive and negative wind load has to be considered. Okay, so it depends on the zoning. It depends on to the locations where let's say let's say when you do a test, for example, the facade test into a laboratory, structural test. So we go with the positive and negative wind load as per the AMA standard, as per the standards. So the wind load which is acting negative and the positive wind load, which are a part of the requirement.
Right.
I don't know whether you understood.
I think they can follow up with a question. There's another question. In a facade, do you consider only the main members, or do you need to consider the whole facade, the secondary members, everything? I think in your presentation, you covered about not only the members, you also designed the fin. So probably you could.
It has to consider it all, yes, because if it is connected each other, so it has to be considered all. Like when you have a fin, so your fin, depth of the fin, the thickness of the fin, these are all has to consider design with respect to your wind which is acting over there, with respect to your condition, right. And then how it connected to your facade, and the whole load between the facade and the fin, how it's then passed, to the brackets and then to the building. So it has to connect, calculate all.
There's another question about this zoning. So the codes actually give the wind or the correction factors for different heights. So how do you decide on this zoning? Is it through wind tunnel analysis, or it could be taken up from the code?
See, that's why when we have a wind tunnel analysis, then we have a different coordinates. As I said, surface condition, corner condition, different zoning of the heights. Your wind load has been given. The coordinates are given. So, as I said, it depends on to the type of the project. If it is a continuous facade, let's say office towers, still there is a way of designing the facade, taking the mean wind load, and then you design, and wherever above the mean load, you can go for a reinforcement. Like many projects that has been done in the past, like you can go for a hot dip galvanized mild steel with a brown baker tap inside the aluminum, or you can go with like different way. So that can optimize the
There's a question from Naveen. What are the roles and responsibilities of a facade designer, and how is it different from a structural designer, or facade engineer and a structural engineer?
The structural engineer, they play the role of the structure, okay? But when it comes to the facade, like, okay, wind load, I would say it is the same. When it the wind load calculations, maybe structural engineer also can do the wind load calculation of the facade based on to the wind tunnel. But while designing the facade, the facade engineer, who is a structural facade engineer, he should understand the facade system. He should understand the the intricacy of the connection between the split mullion or maybe a stack joint profile if it is unitized, how it's connected to the brackets. So I think facade engineer, structural engineer has a adequate experience to understand the facade design. Or structural engineers who I think they're not.
There's another question. As a facade consultant, okay, there are different zones in the building, and if facade fails in one zone, does it mean the whole facade or the whole building is a failure? How hard is it to manage as a consultant?
It again depends. Okay, let's say answer to your question, like if it is a continuous facade, okay, and if it fails, we have to understand how it failed. It failed because of the improper design, because of the inadequate wind load, the actual wind load which is acting over there. We have under designed something, or it is because of some kind of other reasons. You have to analyze the reasons. Right. But if it is localized, if it is for the structural failure, then if one zoning, the structural failure is done on the wind load, wrong wind load calculation, and we hope that the other zone also, we are not sure whether it been rightly been done or not. So whole facade is a risk.
Right. So there's another question. Is the facade connection fix or pin, does it vary with the wind load?
Sorry?
The facade connection pin, the fixing element for the facade to the building, does it vary with wind load?
See, the facade, you mean to say that the facade which is connecting through a bracket to the structure, right?
Yeah, I guess the question is about the brackets. Does it vary with the wind load?
See, the brackets, again, like for the typical, when you like for example, a unitized continuous facade, okay, unitized facade. So when there is a continuous facade, we always design the whole facade before the survey happens, okay? So the wind load acting over the facade. So what we try to do is that along with the different joining of the wind load, you have a factor of safety added up, okay, while designing this. So bracket design as per the wind load which is acting over. But mostly, let's say I'll give you an example. For the 9th floor, if you have a thickness of the, normally you say that the bracket design, the thickness of the bracket, try to go uniform, because it's very difficult to segregate during the construction process what thickness, if you have a different thickness. But if you have the same thickness, you can go with a typical model. But when the bracket at the position of installing at the site, and we have a site survey where there is a undulation of the facade, because of the construction tolerance construction undulations, plumpness or verticals, whatever is there. So the bracket itself has a position of plus minus 25 tolerance. If it is more than the tolerance limit, the structure is in and out, then those areas the bracket has to redesign.
Right. There are a lot of questions. I'll try to rush through. Let me see. Okay, this is another interesting one. How do wind tunnel testing provide more accurate result than CFD analysis?
Wind tunnel testing is a prototype testing. Okay, so what normally do they create a similar kind of model, and with the surrounding, and then they go for a prototype test. CFD is a virtual way. It's like a computer simulation. It's like a simulation. Right. So we have to just consider the surrounding on the basis of our assumptions.
Oh, very good. There's still a lot of questions coming. We're running out of time. Okay, let me take this question. How risk coefficient is assumed with design life while designing wind load?
Sorry?
The question is how risk coefficient is assumed with the design life. Probably this is to do with the building. The risk coefficient, I guess, is based on the building, life of the building. So accordingly,
it's like when there is a facade. So facade, the whole load of the facade and the moment of the facade is directly to the structures. So when there is a structure, when there is a structural design in place for a structures, so the facade load or the total load of the facade, whatever the load is coming onto the facade, we have to give it to the structural guy to check whether they have calculated with that. So the building life which is come into concern is mostly into the structural part of the building.
Okay.
But when there is a facade design, it designed up to the 50 years.
Right. I'll just take the last two questions. Who should determine what kind of wind analysis to be carried out? Should it be the facade consultant or the structural consultant?
As I said, like structure comes first. So when there's a structure, it always go with the wind tunnel report, wind tunnel test mostly. But few they don't want to go, so they also facade structural engineer also go with the conventional way calculating. But when they calculate the wind wind load over there, and the facade which is it is part of the.
Thank you so much. There's just one last question. This is a question which we faced mostly. This is by our friend in Indonesia, Harry. Says wind load calculation is important, but what if we don't get the information from the main contractor or from other bodies? Because many cases windows are neglected. When there is a facade, the developer concentrates a lot on the design. But when just it's a doors and windows, then it's like, okay, just the price is the consideration. So how do we get this wind load calculation, or how important is this, and how for doors and windows especially, how can this be addressed? Because this
doors
is not considered.
Doors and windows. Yes, we are playing around with the openings. The windows coming into within the openings of the structures. So the wind load should be calculated by the facade side for the engineers, for the facade side. What kind of wind load will be over there? We don't. We don't need a wind load calculation. The structures designed on the facade, which is totally a separate subject. Separate entity of the window framing. So window framing, the shutter sections or the track sections, whether I explained before, how it works, that's purely as a part of the facade design. So wind load, facade wind load should be calculated based on that. But sometimes what happens, like when you have a window also as a modern building, is a corner full height 90-degree glass corner windows, you know.
Wow.
So here the wind acting over there are different than the wind acting onto the surface condition. So it's a part of the facade engineer to calculate.
Well, that's all we have time for the question and answer. I'll pass on to Bo to do the to thank the audience and the speakers. And personally, Binoy, it's been really enlightening for me to look at the different buildings, the different design for the buildings. Thank you so much for participating in this webinar and agreeing to make this wonderful presentation.
Thank you.
Over to you, Bo.
Okay, thanks, Satish. Thank you, Binoy, for a great and very profound presentation today. Importantly, thank you to everyone for joining and spend your valuable time in this learning session with us. I think our ultimate goal is to make our community the safe place with all the buildings that are designed and or built to withstand the force of nature. Could it be for high-rise, low-rise, commercial or residential buildings? We are all in this together. So DeCoinic, as one of building material producer of UPVC profiles for windows and doors, we are proud to be a part in this effort for better living society by this knowledge sharing session that will be continued. So please stay in touch and we would reach you again in the next one. Thank you and have a good rest of the day, everyone. Thank you.
Thank you very much.
Bye.